let's look at how we can do 3D design, 3D modeling for laser cutting. So, because with a 3D design, you can create models that can be laser cut, and essentially you're limited only by your imagination. So I've got some sample models there showing you ways that you can do 3D design with a 3D CAD software and laser cutter. So the top left picture is actually a contour topography map. The top right picture, that's actually a sort of finger joints and stuff like that you can use to do, in this case, models of buildings, houses, and let's say desk caddy and stuff like that. You can do a full 3D model and then use additional software to slice it to get the framework of your 3D design. So that's the left middle picture. You can also do curve designs. That's not to say that laser cut models must be flat. Okay, so in order to do the curve designs, you have to implement something called a living hinge. So the bottom right picture is actually your living hinge swaps. So depending on how you cut the slots, you can have different kinds of bending. Now, one of the things there's actually a physics behind it. There's a whole paper telling you for different kind of materials, what are the slots, what are the gaps that you have, spaces between that. But the best thing to do, of course, is trial and error, because it works differently for different materials. Then the bottom left picture is an example of a living hinge case in this. Right. So next one, right. So how to do a 3D laser cut design with Fusion. For Onshape, it's very similar. So I've got two full tutorials there. These are pretty comprehensive YouTube tutorials, where first one is designing a laptop stand with Fusion. So this tutorial actually leads you through the whole process of designing the laptop stand, putting on the different panels, and then doing the finger slots, the joints, and things like that. Okay, second tutorial is a very simple laser cut design, but this time is a simple box. Of course, you can modify, put in slots and cutouts at different places. And one of the things about the using a laser cutter for 3D design is that you can design the parts to be very, very tightly fit. That means held together by friction only, what we call press fit design. You don't need to put in glue and stuff like that. Okay, right. So to help you with the design, there are a number of tools, applications that you can make use of. So one of the very popular tools is this thing called Slicer for Fusion 360. Used to be available from the Autodesk App Store, but they've since removed it, but it is still available for download. Okay, so if you click on the, just search for Slicer for Fusion 360, you get the download link, which I've also put it down here. So you can download, it's a standalone package that you run. So if you've got your STL or OBJ 3D model, okay, you can throw it to the software, and then you can specify how you want to slice the model up. Whether you want to slice it this way to form your framework, or if you got a lamp shape, for example, so just draw the overall body of the lamp shape. They can ask you to slice the panels that make up the panes of your lamp shape.
Okay, Stephen, we're
So there's
we're
a
over.
tutorial that I've linked to learn how to use the software if you want to learn in more detail. Now, one of the benefits of this package is that not only does it slice the models for you based on your parameters that you set into it, but it will also help you to lay out the slices, as well as to number it. So that makes assembling the cut slices into a full 3D package a lot easier. Right,
Stephen,
next.
I'm gonna skip to the
Yeah,
conceptual parts, to the considerations, because we ran out of time. But
yeah.
when you guys get the link to the presentation, there's a lot of slides with pictures and ideas for
Okay.
projects.
Now, one of the things about cutting with the laser, a laser beam has certain width. So it is not zero width or thickness, which means that when you have your model, okay, the cut line is a vector line. So the laser beam will go along the line, center around the line. And because the laser cutter essentially removes material, so there's going to be a gap. So the gap material that's removed by the laser cutter is known as the curve. Right. So this is important because if you are doing a design where you want the parts to be very tightly fit together, then this means that you have to compensate for the material that's removed by the laser cutter. So imagine if you have a finger joint like this. Now, next slide. Next slide, please. Okay, so if you have a finger joint, so if I do the, let's say the finger joint, the finger, protruding finger and the gap at the same width, then after I laser cut the part, okay, there's going to be a gap, material removed by a laser cutter. So when you put it together, it will be loose. So if you want it to be tight fitting, then you have to make the finger part of it, the protruding part, a little bit bigger, and then the slot, the gap part of it, a little bit smaller. So after the laser cutter removes the material, everything fits together very nicely. All right. So example of a press fit kit would be one where after you put all the different parts together, you can actually lift it up without the parts falling apart, without any glue, without the whole assembly coming apart. So I'll show you some example of a press fit construction. So in this case here, I've actually got this is actually an IoT clock. So I've laser cut the part and then with the electronics, everything inside. So I can hold it and the parts are all held together by friction itself. So that's what we mean by press fit. Okay, so if you have joints, there are many different ways to put the joints together. So standard slot, finger joints, that's the bottom right part. And then you can also do this top right, that's what we call the captive T-nut. Captive nut design. So you have a nut that you put in into the slot there, then you have the screw that puts in, and you know, screw the pieces in place. Of course, you can, there are actually plugins on Autodesk Fusion as well as Onshape for doing a jigsaw puzzle kind of design. So give a picture, tell it, turn it into a jigsaw puzzle, it can do it for you. Likewise for Inkscape as well. Okay. Now, every time you do a 3D design and you want to laser cut it, okay, you've got all these different panels. So you need to open it up and then lay it on your workpiece, your stock in order to do the cutting. And there are software. Okay, this process is known as nesting. So Onshape has a feature script that does the nesting for you. Fusion 3, Autodesk Fusion, unfortunately, there's nothing that does the nesting for you right now. I mean, there are some products, but not really full featured. So you can run third-party software to do the nesting for you. So this thing called DeepNest, deepnest.io, it helps you to do the nesting of all your laser cut parts.